Historically, California has been one of the most wildfire-prone regions in the world. In 2020 alone, the state saw over 4 million acres burned, the largest wildfire season ever recorded. But it's not just California. From Oregon to Texas, and even across the world in Greece and Australia, wildfires are becoming more frequent, more intense, and more destructive.
We wanted to understand why and whether we could do something about it.
Hi, I'm Adroot.
I'm Chai.
I'm Shario.
We're the team behind FireSight, a deep learning project that predicts the likelihood of a wildfire based on weather conditions. Our inspiration came from personal experience. We have family in California, and we've seen firsthand how wildfires can threaten homes and communities. Even in Texas, our own community, we've faced the fear and damage of local wildfires. That experience motivated us to ask, can technology help us predict the next spark before it becomes a disaster?
FireSight used a deep learning model trained on historical wildfire and weather data from Zenodo, focusing on real California wildfire records. When a user uploads a CSV file containing weather data, things like precipitation, temperature, and wind speed, our model predicts the probability of a wildfire occurring under those conditions. The output isn't just a number. FireSight displays detailed visualizations, histograms, scatter plots, and risk levels to help users understand why a prediction was made.
We started by cleaning and preparing the Zenodo dataset, focusing on features that correlate strongly with wildfire ignition. We then built a neural network model in TensorFlow and Keras, tuning it through regularization and hyperparameter optimization to reach nearly 80% accuracy. For the front end, we used Streamlit, a Python-based web framework, to turn our deep learning model into a fully interactive website. Users can upload their own datasets, see predictions instantly, and explore dynamic visualizations made with Plotly. Of course, it wasn't all smooth. One of our biggest challenges was getting the deep learning model to stop overfitting. It kept memorizing the patterns in the data instead of generalizing. It was having trouble making accurate predictions. So we researched ways to optimize it and learned about regularization, scaling, and hyperparameter tuning to make it more robust. Using these techniques, we were able to improve the accuracy of the model. We also faced technical issues integrating the model into the web app, especially managing input formats and scaling data correctly. But after carefully perusing our code and a lot of trial and error, we were able to fix all of our issues and make it work.
We're proud that we built a complete deep learning pipeline, trained, optimized, and deployed, all within 12 hours. This model works accurately, and the app includes rich, customizable visualizations that make data exploration intuitive and insightful.
We learned not only about data collection and deep learning, but also how to bridge the gap between raw code and the real user-facing product. And more importantly, we learned how technology can help us better understand and potentially prevent real-world disasters.
In the future, we plan to make FireSight global, integrating more datasets from around the world to predict wildfire risks anywhere. We also aim to improve our model's accuracy and add new environmental parameters like soil moisture, humidity, and vegetation density. Our goal is simple: to help communities prepare, protect, and prevent before the next spark turns into a catastrophe.
This is FireSight.
Predict the spark before it burns.